And tonight with us, we have Nick Howes and Terry Mosley. And we're going to be talking about Mars exploration, past, present, and future of it all. Now, what we're going to do, just to give everyone a heads up of what's going to be going on, we'll let, over the next 5 minutes or so, we'll let everyone join on to give those who are running late an opportunity to sign up and get their Zooms running and find a comfortable position, a cup of tea, and then we'll get going. Hi, Nick. Hi, Terry. How are you guys doing?
We're good.
Fine, thanks. Looking forward to this.
Awesome.
The last time Terry and I were together, we were in the front of a telescope.
That's right, a big one.
A very big. So the Leviathan telescope, which has been kind of rebuilt, restored up at Burr Castle, is it, in
County Offaly in Ireland.
Yeah. Absolutely fantastic. And Terry, bless him, just put out an invite and let me kind of climb inside this telescope. So there's a great picture of us kind of stood in the front of it. It's just amazing. So.
Yeah, it was the biggest telescope in the world for 70 years, and it was in the middle of a bog in Ireland.
First one to allow people to see the structure of galaxies with M51.
Yeah, indeed.
Yep.
Yeah.
Wow, it's crazy. So yeah, another warm welcome to the few more people who have joined us. We'll be starting the talk in about 3 minutes, just giving everyone a chance to get comfortable.
A few familiar names in the attendees list as well, so that's nice. That's good.
And just to give everyone watching a chance, feel free to throw in questions throughout the talk, and I'll try and let Terry and Nick know what they are. But around 6 o'clock, between 6 and 6:15, we'll actually have a live Q&A where I'll hope to answer, or I hope Nick and Terry can answer all of your questions.
We'll do our best.
Right.
So yeah, whilst everyone's jumping on, Nick, tell us a little bit more about yourself.
Right. Oh, gosh. My name's Nick Howes, and I currently work as the lead research and development analyst for a company called BMT. BMT are probably best known for our work in designing two of the most advanced aircraft carriers on the planet, which are the Queen Elizabeth and Prince of Wales. So predominantly we work in the defence sector, but we have cybersecurity teams, artificial intelligence, machine learning, software development, visualization and VR teams, 1,500 people across 35 countries. Main home office is in Bath in the southwest of the UK. And about 2 years ago, we looked at all of the different engineering and research disciplines that we do, and decided that we should really have a go at the space sector, which is kind of where I came in. And we've got a growing space SI team. We've got a new person starting in a few weeks, even during the lockdown. And we're focusing on areas that other companies aren't really looking at. So we work with a lot of the major primes anyway. We work with the likes of Lockheed Martin, BAE Systems, Airbus. So we've worked across the sector with lots and lots of different big space companies. And we now have an office, which you guys will be familiar with, at Space Store at the Harwell Space Cluster in Oxfordshire. So yeah, it's pretty cool.
Awesome. And Terry, what about you?
Right. Well, I'm an amateur astronomer, been interested in astronomy for well over 55 years. So that goes back before the space age, basically. All the observations of Mars and the other planets were done from telescopes on Earth. And my primary interest was the solar system, planets like Mars, Jupiter, and Saturn. Since then, I've followed the developments of the space exploration, both manned and unmanned, and the incredible advances in astronomy there have been over the past decades. It's just unbelievable. It's an amazing time to be alive if you're interested in astronomy and space. So I've followed the exploration of Mars from Mariner 4 onwards.
Awesome. That's exactly what all the people want to hear tonight.
Yep.
And yeah, warm welcome to the few others who've just joined us. I think we'll be starting in about a minute. So I'll just let you, Nick, share your screen so everyone can see your wonderful presentation.
I'll do my best, and hopefully that is now up on screen.
Yep.
Right.
Cool.
And there's still a couple more people joining us now, so welcome to you all. We'll be starting talking about 30 seconds now, and I'll be back at around 6 o'clock. I hope you guys enjoyed the talk, and I'll hand it over to you, Nick and Terry.
Cool. Thanks a lot. Thanks to Space Store for hosting this. It's really, really fun. And Terry for joining me.
Yeah, it's a pleasure, Nick. Good to talk to you again.
Always good. Always good fun. So we're going to it's a bit of a light-hearted, not too serious, but we're going to dip in and out of the science, kind of history of the exploration of Mars and what's gone on in the past, what's gone on in the recent future, and hopefully kind of end up with what's been planned for the future with the likes of SpaceX, NASA, and various other organizations that are looking forward to showing us the red planet over the coming decade or so. So, welcome to Mars. Yeah, you thought lockdown was bad. Mars is, and always has been, a really, really tricky place to get to. We'll talk a lot more about that during the course of the next 45 minutes or so. If you think it's a wonderful sunny holiday place, and Wadi Rum is where a lot of The Martian, which you can see in this image, was filmed by Ridley Scott, it's not. It's typically anywhere between -80 to -100 degrees, sometimes gets up to near zero if you're lucky in the summer. Atmosphere almost non-existent, but enough to cause havoc to spacecraft as they're coming in, and a really inhospitable place, and not somewhere you really want to be. So the thought of traveling to Mars in potentially a 9 months to 1 year mission, then spending another year on the surface and then a year if you were coming back in a spacecraft that may be no larger than a living room and a dining room in an average house, is probably, it's an interesting challenge based on, I don't know what you think, Terry, about what we're going through at the moment in the world.
Yeah, I'm not too bad, I have to say. Personally, I have a garden to go to. I would hate to be cooped up in a spacecraft, even for the length of time that this lockdown has gone, never mind the time it takes to get to Mars or back again. So yeah, I would love to go to Mars, but I'd love it to be an awful lot easier than it actually is at the moment.
Yeah, that's the thing. You only have to go back 50 years to the Apollo era and the Apollo command modules. If people in the listening audience have seen them, they are relatively small, and they were housing 3 astronauts, obviously on the Lunar and the Apollo missions. Between that, the command module, and obviously the lander itself. Not a lot of space in those,
No.
but that was only for potentially a week to 10 days worth of mission, whereas this would be 3 years. So it's going to be a real challenge to get there. So, but on that note, why do we want to go there? I mean, this is an image of some of the earliest mapping that was done of Mars by the likes of Schiaparelli and Percival Lowell from the Lowell Observatory. So in the late 1800s, Schiaparelli had done some observations where he detected what he called canali, which were channels really, but it kind of erroneously got translated into canals. And then Percival Lowell, as Terry will probably be able to tell us more about, then took up the story, built an observatory really designed to observe Mars, sat in this huge, great big telescope, this big refracting telescope, which is still there. Absolutely wonderful observatory in Flagstaff in Arizona, not too far from Barringer Crater, also known as Meteor Crater. And this kind of whole idea of canals and life on Mars, with the whole what was happening with H.G. Wells as well, really took hold.
Yeah, the thing about Mars is it's the only planet in the solar system that we can see actual surface detail on. We can see surface detail on Jupiter and Saturn, but it's only the top of the clouds. Mercury, certainly back in those days, you could not really make out any detail on the surface at all. Venus is totally covered in clouds. And people always believed from way, way back that there was likely to be life on other planets. And even great Sir William Herschel thought there could be life on the sun. which now seems absolutely, totally mind-blowingly incredible. But certainly Mars showed not only surface features, but it showed that it had polar caps, which were thought to be at least partly of water ice, and they are. And it also showed changes on the surface. And it was very, very tempting to believe that that was due to life, but it was simply simple vegetable life that was changing with the seasons, the Mars's seasons, just like the Earth, or whether, as Llewellyn believed, that there was evidence of an advanced civilization. But the focus was always on Mars because you could see that detail. And of course, it was the planet was beloved of science fiction writers like H.G. Wells and so on. And the famous broadcast of the invasion of the Martians really sort of emphasized just how seriously people took that idea.
It was terrifying. If people haven't heard that, Orson Welles,
Yeah.
this is going back about 70, 80 years now, did a radio broadcast that it started out quite well, and it was a radio play about basically the invasion of Earth from Martians, but it was done in such a way that it sounded like a news broadcast.
Yeah.
And it had so many people in the United States panicking and running out in the streets and genuinely believing that we're being invaded by Martians, which is it seems quite strange and silly now, but again, looking at what our planet is going through in terms of a microbial invasion, as it were, from something so small that's wreaked so much havoc, you can imagine how terrified people would have been 70, 80 years ago.
Yeah. First example of fake news.
Yeah, absolutely. So what you can see on the screen now is, as Terry was saying, it's one of the great things about amateur astronomy. This is the images you can see on the right-hand side of the screen, taken from the Philippines by a really, really great amateur astronomer by the name of Christopher Go. There's obviously people like Damien Peach and all other, some really, really great planetary images around the world who've been taking fantastic images of Mars. And the nice thing is you can see it rotating. So if you're up all night during the winter and Mars is in a good position relative to where you are on the Earth, you can see these features kind of rotating around, and some people have created animations quite simply. With a half decent sized telescope, you can even see some of the volcanoes on Mars, because obviously Mars has got some of the largest volcanoes, indeed the largest volcano in the solar system in Olympus Mons, which is area-wise about the size of Texas. It's absolutely enormous, but it's one of those things that you look at the kind of Mercator projection map in the bottom left, and you look at some of the images and drawings done by the likes of Lowell and Schiaparelli, and you can see how they thought that these channels did exist. Because as Terry was saying, you've got these seasonal variations typically caused by changes in dust, dust storms, etc., which are prevalent on Mars. They can cover the entire planet for weeks at a time, months at a time even. And it's one of those things that it's a rarely beautiful thing to be able to see the surface of another world. Apart from the moon, obviously you can see a lot of surface detail on the moon, but it's so close. The other thing that probably got people thinking about Mars as a potential for life is the polar caps. You look at our own Earth, and we've got two very prominent polar regions in the Antarctic and the Arctic. They were looking at Mars and thinking, well, there's ice poles there. That means there must be water, or so was believed, obviously in the days before more advanced observations and spectroscopy, and that could have led obviously to people thinking that there was prevalence of life on the surface.
Yeah, they didn't know then that Mars had such a thin atmosphere. They knew it had some because of the dust storms that you could see. It takes some sort of an atmosphere to be able to whip up dust, which would temporarily obscure parts of the disk, and then that would disappear again. So there was definitely some sort of an atmosphere there. They didn't know then just how rarefied it was. But going back to the polar caps, they shrink and expand with the Martian seasons. So there really was a lot of evidence that there could be water in some sort of liquid form on the surface. Now we know it's not as simple as that, because the ice is sublimating. When it disappears, it goes directly into vapor. It doesn't become liquid water, at least not on the surface. But the other thing is looking for the canals and so on. The human brain has a great tendency to join up very faint, indistinct features and make them into something that actually isn't there. And the so-called canals were very largely a product of human imagination. And probably you have to say, even though they were respected astronomers, there was a lot of wishful thinking involved. They wanted to see canals, and it's very, very easy to join up very faint, distinct features and make them into a line joining 2 points, which is what they were doing. But modern imaging obviously has shown that that simply is not the case.
That's true, and that kind of neatly leads on to the advent of the space age. So obviously, from 1957, humankind has been able to launch satellites into low Earth orbit, and it didn't take long from the launch of Sputnik and obviously the time of Gagarin for both the Russians, the Soviet Union as it was in those days, and the earliest kind of NASA coming from the NACA to start launching and thinking about interplanetary probes. The Russians have had a really interesting track record in terms of success rate, and we'll talk a lot more about that in a bit. But one of the first really successful missions out to Mars, or the first really successful mission out to Mars, was Mariner 4. This was around about the early part of the 1960s, designed as a flyby because orbital insertion, as we'll go into a bit later, is vastly more complex. So just doing a simple flyby of the planetary surface really hit home just what kind of a world it was, or at the time, so it was believed it hit home what kind of a world it was. Because from the first images we got back, and you can look at how poor these were, even compared to amateur images now, we've just seen in the previous slide. But it gave us more of a detailed view of what the planet was in terms of craters, all the things that we didn't expect to find there were then kind of brought into view, and people thought, well, hold on, this is a barren world. This is exactly like the moon, or like any of the other potential worlds like Mercury. This is not going to support life. It's dead. It's a feature. It's a crater popped, featureless as it were, planet. Unfortunately, later exploration kind of put pay to that. But Terry, I mean, you were saying at the outset that you remember Mariner 4. Have you got any recollection of this?
I do. I have to say I was a bit disappointed because those images are, they're not good. But when you think that they had to be sent back over that incredible distance, they were recorded on a tape recorder, basically, and then transmitted back at, I don't know what the rate was, but about 5 bits per second or something. Don't quote me on that, but it was incredibly slow. And the transmitter that they had wasn't really very powerful, so that they got anything at all back was brilliant, and it showed that it was possible. And then improvements in technology gave much better pictures with Mariner 6 and 7 and then 9 as well.
It's true, because you think about now, we've got CCD cameras, we've got vast amounts of computing power even on spacecraft these days, and that's exponentially increasing like almost year by year. As Terry was saying, they barely had computing power at all, very low power transmitters. There's great stories about some of the early Mariner images being hand colored in. So the data would come in this raw binary form, and you'd have engineers with large posters literally hand coloring and hand shading in the images to try and get as quick as possible an image back from their spacecraft. And it's just amazing. The interesting one that I found in the last few days going through some of the history of Mariner 4 was this, though, with Clyde Tombaugh. So Clyde Tombaugh is obviously very famous for being the discoverer of Pluto. And even in the mid-1960s, and there's episodes as well of things like Sky at Night with Patrick Moore and some of the conversations with Carl Sagan, where they still thought that there was a potential for life and vegetation and something happening on the surface of Mars, even up until the mid-60s. This is at the time of Mariner 4. Again, going back to what you're saying about Herschel, Terry, I find this amazing.
Sorry, say again?
I was saying I find this amazing that you're going back to what you're saying about the Herschels and their belief that there was life on the surface of the sun. But even until like the mid-1960s, this is at the height of the ramp up of the Apollo program, and you think technologically we were so advanced, and yet you've got eminent astronomers like Clyde Tombaugh there saying that he genuinely believed that there was still vegetation on the surface of Mars.
Yeah, I know. And of course, you couldn't see the surface of Venus, and we didn't know back then, before the first spacecraft there, that the temperature was so incredibly hot, the atmosphere was poisonous, and the pressure was enough to crush you. But there was even speculation that there was life on Venus. And it's easy to speculate whenever everything is hidden by clouds and you can't see underneath. But yes, it was widely thought that there would be life on anywhere else in the solar system, that it was physically possible for life to exist. I mean, I know that it's almost impossible on the surface of Venus. Some speculation that there could be bacteria high up in the clouds where it's a bit cooler. But basically, getting back to tonight's topic, Mars was the #1 priority for looking for possible life.
Well, it's this idea of the Goldilocks zone. There was a really great talk I attended earlier this week with Martin Griffiths, who's an astronomer based in South Wales, and he was talking about the whole concept of the habitable zone and how now with exoplanets we're trying to determine whether or not there's potential for life on worlds orbiting other star systems. And the thing with Mars is it kind of does just border on the habitable zone around our own sun. Venus is probably too extreme and always has been, but Mars does dip in and out. And this whole thing with what's happening now with the exploration of Mars, and that's still the search for life, because there's still no accurate kind of determination as to whether or not there has been life on Mars in the past, or that there potentially could still be life there. Anyway, so going back to Mariner 4, this was the engineers building the spacecraft. Spacecraft design hasn't changed that much in the last 40, 50 years. You've still got solar arrays for anything pretty much going out towards Mars. A bit further out, you're like more on radiothermo nuclear generators. But the spacecraft concept and design, the electronics on board are far more sophisticated, the solar panels are far more efficient, the transmitters are better, we've got much better computing power. But that's essentially what they had in the mid-1960s. And then moving on from that, as Terry said, we had Mariner 4, then 6 and 7, again, flyby missions, giving us better and better images. But the kicker came, I'd say, late 1960s, early 1970s, with the development and then launch and orbital insertion of Mariner 9, where we really started to get very detailed images from the Martian surface. And even when it got there, we didn't, because the whole planet was shrouded in a dust storm. So they had to wait in orbit and just until the dust storm had cleared. But once it had, the images that were coming back were absolutely spectacular. And we've still got features now like the Mariner Valley, which is pretty much the size of the continental United States. Makes the Grand Canyon look like a small brook in comparison, named after this remarkable spacecraft. So, Terry, thoughts on Mariner 9?
Yeah, that was the first mission that really showed a lot of detail. And one of the amazing things was at the time, although it's not amazing in retrospect, that there were so many craters because you couldn't really see them from Earth. But when you think about it, Mars is such a thin atmosphere that an awful lot of impacting bodies will simply get through and hit the surface. You only have to look at the moon and see what has happened to it. And the other thing was that it indicated that there hadn't been anything like plate tectonics or atmospheric erosion, not to any significant extent, in that a lot of the craters were still relatively sharp-edged, like the ones on the moon, whereas any craters on the Earth have been almost totally obliterated, except for ones that are very recent, like the Barringer crater in Arizona. But that was the revelation. Also, some images of what looked very, very like river valleys, or the beds of rivers, or the tracks of rivers, and also a bit more detail on the edges of the polar caps. So that was a quantum leap forward compared with Mariner 4. And it sort of really sparked the interest to say, for further exploration, saying this is a fascinating planet, particularly the Valles Marineris, the huge valley, and the major mountains like Olympus Mons. It definitely sparked the interest for justifying expenditure for more advanced missions, which did follow.
Yeah, I mean, as you were saying, it was the first detection really that there was potential for things like river deltas, river erosion coming back from these still primitive images. Don't forget, I mean, we're still way before the era of CCD cameras. We're only just at the kind of tip end of the Apollo program, where obviously technology was advancing again at a spectacular rate, but it's still difficult to get there. Mariner 9 was a huge success, but I kind of briefly flicked into this slide earlier. The Great Galactic Ghoul, as it's known, coined, I believe, by Time magazine. So I find it really fascinating that in terms of a success rate out to the outer planets like Saturn, Jupiter, we've had obviously Galileo, Juno, the Pioneers, we've had the Voyagers, all incredibly successful missions. Juno going into orbit as well, some of the most complex orbital dynamics ever achieved. Obviously Cassini at Saturn and Huygens going into Titan. There's been some remarkable successes in the outer planets, which are obviously significantly further out than Mars. But Mars itself still holds this kind of terror for most systems engineers, rocket scientists, for want of a better term, in terms of getting there, because it's incredibly hard. And I think of all, 28 missions have failed to even get to Mars or be fully successful. And I think only about 18 have actually gone into orbit and or landed on the surface. So the same with the Russians. They've been trying since 1960 to get anything onto the surface of Mars, and have had barely any success at all. And we'll kind of go into that now with the first thing. It's a great pub quiz question when people say, what was the first thing to land on Mars? And people say, oh, Viking. Well, it wasn't. It was the Russian Mars landers, Mars 3 in particular, which managed to hit the surface and transmit for about 15 seconds. And what you can see, that kind of TV scanline pixelated mess in the bottom left, is the first image, technically, from the surface of Mars. And it's beautiful to find now with the high-rise camera on one of the orbiters, some of the detailed images that have been able to show these crash sites. But it's hard, isn't it, Terry, to get there?
Yeah. The thing about Mars is it does have some atmosphere, and you have to allow for that. If you don't allow for it, your spacecraft is going to burn up on the way down. So it's not like landing something on the moon where you simply use retro rockets, you have nothing else. On the other hand, the atmosphere is so thin that it's barely dense enough to slow down a spacecraft coming in from the velocity that it has being sent from Earth. So you're in a sort of a quandary. How much do you rely on parachutes? How much do you rely on retro rockets? When does one take over from the other? Whereas the flyby missions were relatively simple, the orbital insertion missions were relatively simple, but there have been so many different techniques tried to get soft landings on Mars. A combination of retro rockets and parachutes and the big bouncing balloons and so on, and the sky crane and so on, which we'll probably talk about later. So that made the attempts to soft land on Mars more complicated, because you were allowing for several different factors. The braking effect of the atmosphere, you also had to allow for the ablation, the heating effect of the atmosphere when you're coming in, and then you wanted a soft landing at the end of it. So it was a couple of extra layers of complexity, and I think that is responsible for quite a few of the failures.
Well, that's the thing. You're typically arriving at the planet at anywhere, 20, 30,000 miles an hour. And then typically what they'll do is they'll dip in and out of the atmosphere to slow and to kind of break the spacecraft to a limited extent. But you're still then hitting the atmosphere at hypersonic velocities. And then you've got to deploy a parachute. And some of the parachutes, that have been tested for the recent landers, they're absolutely enormous. And they've got to take almost like hypersonic velocity shocks on deployment. Some of them, it depends on the parachute, but some of them tested 700-800 miles an hour coming out the back of a spacecraft, and higher velocities. And as you said, then you've got to have the combination of the parachute deploying at the right time. You've got to jettison weights, so you'd have balance mass weights, which would, kind of change the orientation of the spacecraft. Then you've got to deploy the heat shield. Then you've got to take out the back shell. Then you've got to land the spacecraft on the surface, either with balloons or retros or whatever. And then the whole thing with retros is obviously more complex, because you've got an inordinate amount of dust on the surface, which you don't want to be clogging up the instruments. So kind of brings on nicely there to the first true success in terms of landing on the surface. And this is kind of where I got into astronomy and space at the tender age of about 7. Watching the Viking Landers, and I thought this was absolutely remarkable. And Carl Sagan there, quite instrumental in a lot of the kind of popularization of space science over the years with his Cosmos series, standing next to Viking to give you an idea of just how big it is. The image in the top right is the first ever image taken from the surface of Mars. And that's what I love about NASA as well. They don't delay with images. They kind of get them out really, really quickly. The image in the bottom left is the really much more detailed images that we were getting from the Viking orbiters, because don't forget, Viking wasn't just landers. There were orbiters who were successful, and in some cases are still there. They're still orbiting. They're defunct, but they're still in orbit around Mars. And then some of the scientific instrumentation in the bottom right, the ability to dig and deposit samples into this incredible science laboratory, which included biological experiments for labeled release and looking at the potential for life on the surface of Mars back in the 1970s. And we still don't know what the results are from that accurately, do we, Terry?
Yeah, sorry, you're dropping off a wee bit there, Finn. Could you just repeat the question?
I was saying we still don't know what the real results from the the labeled release experiment and the biological experiments are on Viking. They're still in debate to this day, and that's like 40 years later.
Yeah. Nothing is clear cut, particularly when you're doing everything remotely. If you have got the samples in a lab on Earth, you can do repeat experiments, you can try different techniques and so on. But a lot of the stuff is on the edge of detectability, and also there are possible multiple explanations. For example, methane. It can be created biologically, but it can also be created basically chemically. So interpretation is very much a matter of debate between different scientists. Even the famous Martian meteorite, which had the Allen Hills
84001, yeah.
Which possibly showed evidence of tiny little microbes, and there was a huge debate about that at the time. But the consensus now, even from scientists back on Earth, is that probably they're not evidence of life. But nothing on Mars is absolutely clear cut. We still don't even know what caused the Valles Marineris, for example.
Absolutely.
Yeah.
And you only have to look at the label release and the whole debate over percolates and what was causing it. These salts, the percolate materials that were kind of almost fudging the results, as it were. And it's, as I said, to this day we still don't know. And that's probably what caused then what I would call this huge hiatus. So from 1976 with the landing of the Vikings, and they were operational for a few years afterwards, up until 1997. There really wasn't any kind of desire to go back because people had said, well, there isn't any life there. But then the interest kind of got sparked again. And NASA took a really brave step, as you were kind of alluding to before. First of all, in putting the rover on the surface. And this is the thing that almost broke the internet in its early days in 1997, when Sojourner and Pathfinder landed on the surface of Mars, and people could view this on NASA's website. And they had, I think, at one point over 1 million people trying to view these cameras. And these images coming back from Sojourner. I mean, this thing's tiny. This is like the size of a slightly large radio-controlled car that you'd have, give your kids for Christmas. But the first steps that it was taking were quite significant, and it was the first test really of this balloon-based landing system, where you've slowed down the spacecraft enough that you can bounce it off the surface by essentially firing up airbags around it, and it worked.
Yeah, that's what I was referring to earlier. It really is a very simple system, but you have to get the velocity reduced down to something reasonable before that would work. But you couldn't use that for a big, heavy, multifunctional spacecraft that they're using now. You couldn't put something the size of a car inside those balloon things and expect it to survive an impact like that. But it worked for that one.
No, it's a fantastic thing, and you can imagine. You look at the image on the left, and all the number of sharp rocks, etc. The potential for disaster with this was quite high, but still. And Sojourner was roving around for quite some time on the surface, delivering fantastic science and proving that you could put a rover on the surface of a distant planet. Don't forget, the only time this had ever been done before was the rovers on the Apollo program from Apollo 15, 16, and 17, and they had human drivers. And then you've got the light round trip time of 20 plus minutes, where the level of autonomy that now has to be developed in some of these rovers, and we'll touch upon that in a little while, has got to be so precise so that they can almost take control themselves and decide where they're going to go, what they're going to observe, and how they're going to move, and if they're going to be able to move safely. And sorry, Terry, go on.
Yeah, I was just going to say, just looking at that photograph, it draws up another point, and that is powering a rover on Mars. Solar panels are obviously the main source of electricity and so on, but they are subject to two main factors. First of all, Mars is on average a lot further away from the sun than the Earth is, so the amount of sunlight is greatly reduced. It obviously has its day, which is only about 40 minutes longer than the Earth, so it spends half of the 24 hours 37 minutes in darkness. And also there's the problem of dust storms, and we saw that then with later spacecraft where the dust storm obscured the amount of sunlight so much that the power failed. So you have the choice of using solar panels and a nuclear generator, and that has its own problems, but it's just one of the many issues that you have to address if you're putting something on Mars that's expected to last for a long time. And some of them have, as we'll say later, exceeded their mission lifetime by a factor of what, 20?
I'll keep going. It is incredible. And you say about the dust, it's not only the fact that you've got dust, it's highly corrosive. You only have to look at the wheels on some of the rovers, how they've been literally torn apart by a combination of rocks and this really corrosive material, because Mars gets its color from this kind of rusting that's happening on the surface. But also you've got the temperature variations. So if you've got sensitive electronics and you're going into a Martian night, as Terry was saying, it's vastly further away depending on its position in orbit from the Earth, and the temperatures can drop quite significantly between daytime and nighttime even. But obviously on a seasonal basis you're looking at massive temperature fluctuations, the likes of which, I mean, obviously on the lunar surface they've had, but the rovers on the lunar surface were only designed for maybe a couple of days, with humans being there as well, and these things have got to operate autonomously or semi-autonomously for, potentially in the case of the MER rovers, for years at a time. I just want to touch on this graceful, wonderful failure, the British. I'd say a failure. This is the only thing that a Russian launcher has ever got onto the surface of Mars successfully. So Beagle 2 was a wonderful little spacecraft, ran about the cost of a Premiership football player in terms of its total budget. So very, very low cost, pioneered by the guy in the bottom left, who's sadly no longer with us, Colin Pillinger, and his team based at the Open University and the University of Leicester, people like Mark Sims and Ralph Lorenz, some great people who went on to work on spectacular missions, including Huygens, for example. But the thing about Beagle that people don't recognize, they say, it was a failure. Well, it wasn't. It made it to the surface, and some of the images from the high-rise camera show that. It made it successfully to the surface. So entry, descent and landing, EDL phase, it managed. It deployed its parachutes, it unfurled some of its solar panels. So it got down there, and the scientific package on Beagle was spectacular. They managed to take equipment which previously had been 4 or 5 times the size and put it into something the size not much bigger than a bicycle wheel in terms of the area of the spacecraft. And I remember what I was doing watching that on Christmas a few years ago, kind of praying almost, thinking, please succeed, because everyone was so skeptical about it. And the European Space Agency, they were very damning about the level of testing and the mistakes, but then it was found to have worked on the surface. I think it's one of those wonderful kind of British semi-success stories. I don't know what you think, Terry, about Beagle.
Yeah, it was almost a success. It only needed sort of the one other panel to open, and it would have been okay. I don't know the exact details, but you can see from the image there on the right that 3 of the panel things opened, but the other 2 didn't. Something jammed. If all 5 had opened, or sorry, 4 had opened, leaving the main unit exposed, then it would have been a success. It was pretty close.
Yeah, really, really amazing. Back to success stories, though. Steve Squires, who's mission PI for the MER rovers, Spirit and Opportunity, I bet he never thought he was going to have the rip-roaring success that he did. I remember being sat in a bar at Caltech in Pasadena talking to the guy who was driving the rovers just after Spirit had kind of got stuck in its sand trap, and they were looking at how they were going to get around it. But you only have to look at the stats in the top left image there. And to think that between the 2 of them, it's 20 plus years of exploration time on the Martian surface, huge distances traveled, and all solar powered, and again bounced with balloons onto the surface. And it really gave us a true feeling for what Mars was going to deliver in terms of future science. And I don't know what you think about Spirit and Opportunity, Terry, but I love these missions.
Yeah, they were absolutely amazing. They weren't quite autonomous, but they had to sort of operate on their own for quite a while, particularly with the time delay in sending the signals. But I followed them, and the way they would identify a target up ahead and go up to it very, very carefully and look at it, and then they'd look at the images and select another target and move on to it, all very, very slowly and cautiously. But obviously you don't risk your hardware whenever you've got it that far. But yeah, the images they sent back were absolutely amazing, and there's a lovely panorama there of the view, and you could look at that on a large screen or a large print and go over it with a magnifying glass and spend hours looking at it.
Yeah, because it was showing depositional layering. It was showing really the first time direct evidence of that there had been water on the surface of Mars, and to be going for as long as they were going for, and people almost became emotionally attached. They talk about Rosetta and the whole emotional attachment with these rovers. People genuinely started to get emotionally attached to them. It was that kind of almost humanoid look with the pan cam and the configuration of the cameras and the little selfies it would take, and it was just, they were amazing spacecraft.
Yeah. NASA got in on the PR. Sorry, NASA got in on the PR aspect very carefully by getting these selfies. Yeah. And it did encourage people to actually identify with them, and they had their own little personality almost. So as you say, a lot of people were actually emotionally upset whenever the missions came to an end.
Yeah, absolutely. So NASA took this great big leap, but then it needed something bigger. It needed something even more spectacular. And this story I absolutely love. So the guy in the middle kind of pointing out was a chap called Adam Steltzner, who is one of the kind of lead scientists on Curiosity, or Mars Science Laboratory. And his story is amazing. He really is a bit of a rock star. He's kind of a bit of a college dropout. As he said, he was studying the kind of rock and roll, sex and drugs and rock and roll lifestyle. And he was driving home one night and he looked up at Orion and thought, this is really interesting. And he was looking at the different positions of Orion, decided to go back to school, as it were, and study astronomy and study physics. And then he came up with this absolutely insane idea of a sky crane, of basically having a spacecraft descend almost to the surface of Mars and then drop on glorified piano wires the main rover, which is the size of a Mini Cooper, as Terry was alluding to before, onto the surface. The guy in the top left, Bobak Fedosi, this is a kind of, again, an homage to kind of how NASA have really embraced the whole PR side. In the 60s, you had everyone in white shirts and black ties and their kind of little clip pens. And to move from that into this era of really embracing how society and how the public can respond to spacecraft, I thought was amazing. And I remember watching this, and within a few minutes of it landing on the surface, we were getting images directly back. But that 7 minutes of terror video, if people haven't seen it, just find it on YouTube. It's an incredible video that kind of shows just how complex this mission was and how insane everyone thought he was in proposing it.
Yeah, I mean, it was a very ambitious mission. As you say, so many different aspects to it. Everything had to happen, not only in the right sequence, but exactly at the right time. Because, you do it a bit late and the sky crane is too high up whenever it starts to send the thing a bit too late and you've hit the ground. It worked with sort of almost unbelievable precision to fractions of a second in some cases. So it just shows you, if you're bold and if you do all your checking and all your testing right, you can do it.
Take risks. And again, this kind of leads on a little bit. I'll go through this quite quickly. To the Indian mission, again, the cost of a Premiership football player, and nobody thought this was going to be a success. But the Indian MOM, the Mangalyaan, I hope I've pronounced that correctly, Mars spacecraft, very small spacecraft, very simple instrumentation, but quite amazing feat for like about $60-70 million, which obviously is a lot of money. But to get a spacecraft into orbit around Mars that's still working to this day, I think was just astonishing.
Yeah, a year and a half still going.
Yep.
And it's not hugely ambitious in terms of the science. It was partly a demonstrator of the technology and the fact that they can do it, but success on the first attempt, and as you say, for a very, very minor cost compared with any of the NASA or ESA missions.
Yeah, I mean, you go back to the next rovers, obviously we've now got Perseverance, Mars 2020, which is a kind of expanded version of MSL and Curiosity with core drill capability, more options for kind of looking for the precursors of life and the potential evidence for life on the surface. Big nuclear power station on the back of that, as you said, because solar panels, when you're talking about instrumentation at this kind of size, really, really complex. But I'm really looking forward to this one because it's due to launch in the not too distant future, 9 month to a 10-month round trip there, or time to get there. Hopefully, again, using the sky crane successfully to get it on the surface. What do you think we can expect to get from this one, Terry?
Oh. I'm not familiar with all the details of the missions, but it will obviously hugely extend the area of exploration. It's going down in a crater which has already been identified as a very promising candidate for looking for sources of previous life. There's been a lot of water activity. There's evidence of chemical activity with possible biological aspects to it as well. There's so many, I think it's 8 or 9 different aspects to that mission. Any one of them, if they succeed, will greatly improve our knowledge. And if they all succeed, it'll keep scientists busy for the next 15, 20 years.
Oh yeah, absolutely. Yeah. And that whole thing, that debate of the methane in particular, because we've had detections from the European Space Agency's Mars Express spacecraft was one of the first to detect this methane hotspot, as it were, and you can see that in the bottom left on the image. These kind of seasonal variations in methane, and we're only talking about parts per billion. We're not talking about high concentrations, but methane production. It needs something to keep it going, and as Terry was alluding to before, we've either got a chemical process involving rocks, olivine, etc., that could be producing the methane, or, and this is the big or, we've got subsurface microbial activity, and that would be amazing. It'd be the first evidence, obviously, of life on another planet. I've got a bit of a vested interest in this. The right-hand side of the image is a little project I've been working on for years called Median, which is a kind of high-velocity impactor designed to sense out methane and tie in with a rover and kind of encourage the rovers to go in certain directions by providing very, very detailed kind of accurate levels of methane at specific points within the landing ellipse. But it's going to be a very interesting time, as you were saying, Terry, between what's happening with Mars 2020, obviously this search for water and methane, potentially subsurface life, and then the European Space Agency aren't too far behind now. They've had to have a little postponement due to some of the parachute tests failing, but the Rosalind Franklin rover, named after the fantastic scientist who helped with the whole discovery of DNA, didn't really get sufficient credit for it, but that's a whole other debate waiting to happen. But this is a huge leap forward for kind of European science, as it were, with this rover. Again, about the size of the NASA rovers, but designed to drill down to really start looking for evidence of life. Are you excited about this?
Yeah, and it's good to see that Roscosmos, the Russian agency, are involved in this as well. It's not purely an ESA mission. The thing about exploring Mars is that while we're looking at it is now, there's a huge amount of evidence that Mars had a lot of water in the past, oceans of water. It also had a much thicker atmosphere. And from what we know about the development of life on Earth, once it gets started, although the conditions on Mars now are pretty hostile, if life ever started on Mars, it has almost certainly found some sort of niche where it's still surviving below the surface, where it's protected from the excesses of temperature, where it's protected from radiation, and so on. So we think that in the past, and we're talking about millions and billions of years ago, Mars was a planet where life was certainly possible in terms of its development evolution. And if it ever did, from what we know on Earth, where bacteria survive in the most hostile, extreme environments, from highly acidic and highly alkali environments, extremely high temperatures, extremely high pressures, if there ever was life on Mars, I would bet that it probably is still surviving somewhere below the surface. And that's really what the whole thrust of these missions is about now.
Oh yeah, you have to look at the extremophiles, like Bob Ballard, etc. Some of the deep sea exploration work that he's pioneered over the years, and as you said, extreme pressures, extreme temperatures, extreme levels of acidity, and we're still finding life. So everyone's fingers crossed, I think, for the next 10 years and potentially the discovery of life on another world. Yeah. I'm going to briefly flick through this because there's not a lot that needs to be said about this. This whole human exploration of Mars now. So we've got these kind of joke missions. I mean, Mars One was always, and every scientist in the world, I was screaming from the rooftops about this, and I know Johnny O'Callaghan, etc., and various other people were saying the same, that it was just a complete scam, this whole idea of a game show on Mars, and it was never going to happen. But kind of moving on from that, we now move on to Elon Musk. Now, his recent tweets have been a little bit interesting. shall we say, in terms of, you know, what he's been saying to the world, obviously not only with SpaceX, but with Tesla and threats he's been making and the share price collapsing and all sorts. So maybe lockdown's getting to him a little bit too much. Who knows? But he has got very, very serious ambitions for Mars, and you can't count the guy out. You only have to look at Falcon 9, Falcon Heavy. Falcon Heavy was just amazing. Watching the twin cores landing in parallel, it was like Thunderbirds. It was Jerry Anderson happening in real time. And you only have to think, you know, the criticism, and, you know, I've sat in meetings where people have said in the past, oh, what's this guy from PayPal know? Well, he clearly knows enough to be able to do successful, like, vertical takeoffs, landings. He's, you know, now about to launch the first Americans from US soil up to the International Space Station. So clearly he is an engineering genius, but there are some fundamental flaws, I think, in what he's proposing, specifically the timescale. Obviously with issues of radiation, with food supplies, with bone mass degradation. There's a whole tranche of medical problems, the technical problems that have still got to be solved before he gets this, which is his kind of desire to put not only these enormous rockets vertically landing on the surface of Mars, but also a base. So your thoughts, Terry, because I know you've got some interesting thoughts on Elon as well.
For a technical problem, there is almost always an engineering solution if you throw enough money and time at it. And the money he's obviously got, the time he can do it, but probably not in the time scale that he's talking about. There's just simply too much to do. But one thing that you can't solve that easily are the human and medical problems. Now, he's talking about a very fast flight time to Mars of normally we allow about 18 months, but he's talking about a matter of a few months, which does reduce the time that you're exposed to radiation and to weightlessness and so on. But there's still a lot of evidence that prolonged exposure in space affects every part of the body, including the brain. Now, to get the human crew to Mars that quickly, you really do need a very, very big, powerful rocket. You also have to have your life support system there on the surface, ready, waiting for you. You can't just walk into your nearest burger bar and get your grub. Everything has to be there waiting for you. And then in terms of the return flight, he's counting on being able to make rocket fuel from the materials on the surface of Mars. As I understand it, well, he's going to have very, very powerful Raptor rockets, Raptor engines to get you there. I don't know whether they're going to work that easily with the sort of fuel that he'll be able to generate on Mars. But if you don't try, you're not going to succeed. Some of the things he's done so far were things that nobody else attempted, not even NASA, although technically they could have. They could have brought rockets back down to Earth and landed them again. He could have done two simultaneously if they'd really wanted to. He was just the first one to try it and did, after several attempts, succeed. But getting a human crew to Mars, keeping them alive and bringing them back again is many orders of magnitude more difficult than what he's already done. But I wouldn't say that he can't do it.
I think it's the timescales that's kind of making everybody think he's a bit, you know, a lot of scientists and, you know, systems engineers, etc., that I talked to over the years have said, yeah, we are going to Mars. There is no doubt in that. It's the next step forward in terms of human exploration. But the back end of the 2030s is where most people think we're going to be by the time we've really solved a lot of the technical issues, you know, put up staging posts, been able to land successfully, the supply systems. You know, it's The Martian. It really is The Martian. They got so much of that film right, where you've got a large transfer spacecraft in Hermes. I mean, you're not going to be sending anyone to Mars in something the size of the Orion capsule, for example. You're going to need a larger, and obviously Lockheed Martin and various other companies are working on much larger staging posts and orbiters, etc., for that very purpose. But this kind of staged approach, we've not been to the moon in 50 years practically. So we've lost all of that inherent knowledge that we had just from a few days of lunar exploration, and that's only 250,000 miles away. Whereas Mars, you're looking at, you know, hundreds of millions of miles. tens to hundreds of millions of miles away, depending on where you are in your orbit. You've got very limited orbital transfer type, transfer capabilities. You've got to wait for, the planets to be suitably aligned, as it were, before you can attempt even to get there at these breakneck speeds that Musk is talking about. It's as you said, a whole order of magnitude more complex than even just going back to the moon, and we've not been back to the moon yet.
Yeah. The other thing is that astronauts, even on the International Space Station for 6 months, where they can exercise and where they can move around and so on, when they land back down on Earth, they're almost crippled. They cannot get out of the spacecraft themselves. Now, admittedly, the gravity on Mars isn't it's about 40% of what you have on Earth, but they will be in a spacecraft where, as far as I can tell, they won't have room to exercise properly, so they'll be suffering all the problems of muscle wastage, of decalcification of the bones. There's no plan for an artificial gravity, so they'll have effects on their balance, their vestibular system, and yet they're going to have to walk out of that spacecraft when they land on Mars themselves and make their way over to whatever habitation module is there waiting for them.
And not fracture anything.
Yeah, be that easy.
No, it's really not going to. I mean, Hermes, obviously, in the movie The Martian, they had an artificial gravity system on board, but as you said, this is not going to be happening. With and you only have to look at some of the larger, the ISS is the largest thing we've ever put into orbit. But you look at Skylab and the room that they had on that, you are looking at something really a minimum of that size to be able to do this effectively. And you only have to look at the scale of the rockets that I've got on screen now. SLS is not even the size of the Saturn V, the initial SLS. Block 2, 1 going to be larger. Starship, if it happens, and it really still looks like, it potentially could, the pressure tests, he's blown a few up. He's now got pressure tests working. As I said, don't count him out, but it's still a massive leap in terms of what we've got so far and what we've done so far.
But if anybody can do it, I think he can do it. He really does have a genius idea for what is possible, and he's succeeded in everything he's tried so far. Maybe not at the first attempt, but he has succeeded.
Well, that's it. He doesn't give up. Kind of leads almost to the end with, as kind of alluding to NASA's kind of more detailed plans, as it were, and their more long-term plans to return to the moon and then go on to Mars. And you've got, like I said, the likes of Lockheed and the consortia that are now looking at lunar exploration with Draper Labs, backed by Jeff Bezos, etc. Northrop Grumman, various other companies all kind of joining together, which is probably, I think, the right way to do it. It's how it worked in Apollo, where you had lots and lots of big companies all kind of vying, working on different elements and components. The kind of deep space habitat, as it were, that you can see on the left there is probably what you're going to need. But as Terry was just saying, you're not going to have enough room. You're not going to have much room. They're saying about 70 meters squared or 70, about 70 meters squared of per astronaut, depending on how many people they send there, which for a period of 2 to 3 years is going to be really, really tough. And then the radiation issues, you say about the radiation, even if they do it in 2 or 3 months, you only have to look at what happened in Apollo 17. And they narrowly escaped being kind of fried by radiation. The sun can go from quiescent, which it really is now, and there's nothing much happening on the surface of the sun at the moment, to extremely active, and you only need one big coronal mass ejection in the right direction. And the level of radiation people are going to be exposed to, unless they've got proper adequate shielding, is going to be extreme. So it's going to be a tough one.
Of course, you've cosmic radiation all the time.
Absolutely. Yeah. And then, kind of last but not least, before we kind of go into the Q&A, and I know we've overrun a little bit, is the European Space Agency and NASA kind of been toying for years. This is going back to 2006, and this isn't going to be returning samples till about 2031, 2032. But the whole idea of sample return missions, this is interesting because if Musk has his way, he'll have landed people on the surface before this even gets there and brought people back. But the idea of being able to bring back pristine samples, you only have to look at Hayabusa and some of the Comet Interceptor missions of the past few years, being able to bring back pristine scientific payloads from orbit or from the surface of another world. And we're still looking at the Apollo moon rocks now 50 years almost later, and they're still opening up new canisters that were brought back from Apollo 50 years later because we've got much better instrumentation, much better scientific understanding. And I think this is going to be a really interesting test to see, just what's going to be viable, hopefully later in the 2030s when human beings possibly do get there, unless Musk, does break every record. And I love this, the whole, with Perseverance going to be going there and collecting these samples, putting them in canisters, and then potentially, future missions landing on the surface, collecting the samples and then launching them back into orbit, then bringing them back to low Earth orbit, and then descending them back to the Earth. It could be an amazing time. I'm a big fan of meteorites, as Terry knows, and a lot of the people here know. Big fan of meteorite collecting. I've got some Mars rocks that have been blasted off from those craters that we saw earlier, and intercepted the Earth. And I've got lots and lots of different Mars rocks. But this, to have really pristine scientific samples, I think is going to be fascinating.
Yeah, I have a Martian meteorite myself, but the thing about the meteorites is you don't have their provenance. You don't know exactly where they came from.
No.
There's nothing to beat actually getting a sample that you want. You identify the sample, you bring it back, and you study it then in the laboratory. Hopefully in the future, whether Musk gets humans on Mars or not, we'll be able to develop artificial intelligence, which will be able to make much more intelligent decisions on what samples to actually collect and bring back. So that's another possibility for the future.
It's interesting though, you look at Apollo 17, and the reason they put Harrison Schmitt on that mission was he was a geologist. And again, robots can only do so much. We've really got to get, and I know this whole discussion's been about we're not going to get there this year, and the premise behind this is we're not going to get there in the next year or so. We do need to get boots on the ground, and I for one really hope within the next 10 to 15 years that we do.
Yeah, very much so. Should we go for QA? Have we time?
Yeah.
Thank you so much, guys. That has been absolutely amazing. We've had so many questions pouring in throughout. And yeah, as we said, we'll be extending by 15 minutes. So we'll be here until 6:45 answering your questions. The first one is quite an interesting one from Artash Nath. And he says, will the rise in the number of missions to Mars because of new players, so private sectors and space agencies, with their different objectives like mining and dominance, lower the biological planetary protection afforded to Mars?
This was my big problem with Musk's original plan, this whole putting several hundred people in Starship and dumping them on the surface. And again, the major problem I had with Mars One, even before any detailed analysis proved that it was just a ridiculous scam mission anyway. The issue is that you've got very, very tight regulation on planetary protection as it stands. NASA have got class 10,000 plus clean rooms at NASA Goddard, and various other sites like JPL, and they're designed to keep these things incredibly clean. They're designed that no kind of foreign body arrives on the surface of another world. The Schiaparelli disaster, in recent times, has proved that you really don't want to be dumping organics all over the surface of a planet. You really don't want to be putting, as the Andromeda Strain movie said, the dirtiest thing in the solar system onto the surface of another world, being the human body. So I'd personally like to see proper scientific exploration with astronauts, geologists. The whole Martian thing was right. You do it properly first. You send a small group of scientists who really know what they're doing, who are going to adhere to these policies, really make a concerted effort to keep the planet as pristine as possible, so that we're not contaminating it and we're not fudging, potentially the discovery of life. It's one of the biggest questions in the universe is, are we going to find life elsewhere? So I, for one, hope that the commercialization of space doesn't go too far too quickly. I don't know what you think, Terry, but
yeah, absolutely. I don't think Musk has any particular concern for anything other than his own ambitions. If you look at the Starlink satellites, it's a completely different issue, but it just shows that what he wants to do, he does. The thing about sending a spacecraft to Mars, you can sterilize the spacecraft. You can't very well sterilize the humans on board. But there are ways and means of making sure that whatever you're studying on Mars has not been contaminated. And if all else fails, you can look at the DNA and the chemistry, and if it's from Earth, you'll probably be able to identify it. If it's from Mars, again, you can probably identify it. But you certainly don't want to contaminate your samples. But I agree with you, the only way to really do it properly is to get scientists there, geologists, exobiologists, chemists, and so on. They have to be able to study, search for what they're interested in, look for it and study it, rather than just take samples at random.
Yeah, either that or we're drinking bleach.
Yeah.
Yeah, and I hope Ronan Newman, who had a similar question about kind of leaving bacteria behind from a previous mission and then discovering it in the next mission. I think that answers your question, Ronan. But thank you for your question. Another one just coming now from Kaylin Grafton. I hope I've said that right. Is, are there any UK capabilities or companies that may enable Mars exploration? And do you think that the UK government are interested in space exploration and see it as a strategic objective?
Massively. The Rosalind Franklin rover is principally being designed and developed by Airbus out of Stevenage. Beagle obviously proved that there was the appetite there in the past. I mean, the UK Space Agency have a really strong mandate now for developing UK launch capability. This is one of the things that we're looking at the Harwell campus, where we've got an office. My company's got an office up there. There's numerous companies vying for launch capability out of Scotland. You've got Spaceport Cornwall and Virgin Orbital, based out of Newquay. So they're not just looking at the scientific instrumentation, but the British are amazing at this. You only have to look at the James Webb Space Telescope. One of its principal instruments, MIRI instrument, is UK designed out of Edinburgh, the ATC, I believe, up in Edinburgh. We've got a long history of fantastic instrumentation that it's been all over the solar system. You only have to look at companies like CISIS, for example. A lot of the software that was developed for Rosetta, Mars Express, etc., has come out of CISIS, who are based out of Chippenham, quite near where I live. So there is a huge interest in the UK being a big part of this. And I mean, it's one of the things, we've obviously undergone Brexit in the not too distant past, and there was a lot of concern and, discussion about the impact, and it has had a massive impact on science, don't get me wrong. The Galileo program, there's been a whole tranche of different things that it has impacted on, but I think the European Space Agency being Brexit agnostic and independent, I think there's still this huge involvement from the UK in terms of scientific delivery. I think what's happening now with COVID may put a lot of that on hold, unfortunately, because the economy is going to be in free fall. There's going to be an awful lot of funding which is going to be required for medical research and to kind of get the economy going again. So there'll doubtless be an impact, but I think hopefully from a space science perspective, we just need to keep going forward. It's one of those things that we need to understand.
Yeah, there's been so much expenditure already on the missions that are in planning that you couldn't simply abandon them. They may have to be put on hold for a little while because of the budgetary constraints. But as you were saying, while we're not launching rockets directly ourselves, the systems and subsystems that are all contracted out, there's a huge amount of involvement from British science and engineering and research throughout all these missions.
Yeah, you only have to look at Harwell. There's upwards of 100 companies in the space sector at Harwell, ranging from tiny little SMEs like 2-3 person operations up to really big global players that have got offices there. And I think the UK's, as Terry was saying at the beginning, it's a really interesting and exciting time to be involved in space science. It's like I've never seen, in years. It's almost like we're on the cusp of the Mercury, Gemini, Apollo era again, where there's a real space race happening, but it's more the commercial entities that are driving it rather than the governments.
Yeah. Awesome. I think you mentioned Apollo there, and we're kind of going towards the kind of manned missions towards the end of the talk. But there's a really good question coming from Athade Kyoko. I hope I've said that right. And he says previously, so Apollo and Gemini and Mercury missions, basically most of the astronauts in the past have kind of been a military test pilot with an engineering degree. That's kind of been the role model for an astronaut. But going forward, I know you say 10, 15 years for any kind of Mars mission, manned or unmanned anyway. But what kind of mix do you anticipate for the first manned Mars mission for the astronaut?
I would hope, I mean, NASA have got a real stated goal to place a woman on the surface of the moon in the Artemis missions. Yeah, the old days of the test pilot mentality and mindset, it was important in those days. You were looking at extremely complex systems, very dangerous. I mean, I knew a lot of the Apollo astronauts, and you talked to Gene Cernan before he passed away, and he said that the most complex thing he ever did was landing on an aircraft carrier. It wasn't landing Apollo 17 on the lunar surface. but they had to have that kind of do or die test pilot mindset. I think now with a Mars mission, hopefully a 6-person mission, a good mix of male and female, a good mix of different nationalities, nations. Hopefully everyone who's contributed to the Mars exploration program will be involved. That's what we need. We need, again, going back to The Martian, there was so much right about what Andy Weir did. And, you know, he was very clever in getting peer review from various people at JPL and NASA and saying, well, is this right? Is this right? The whole mix of what he had there, where he had botanists and he had geologists and he had, you know, different scientists with different disciplines, is what we're going to need. And you only have to look at the ISS. You know, not everybody on there is a test pilot. Not everyone on there, you know, they can all fly planes. They can all, you know, they've all passed the NASA qualification standards. But there's a whole range of people, and with the growth now of space tourism kind of looming large, Virgin Galactic, and again, going back to Jeff Bezos and Blue Origin, I think that era of it being a very niche thing for a very select group of people hopefully is in the past, and we can move forward from that. So, Terry, any thoughts?
I'm sorry, I'm finding it quite hard to hear Lakshya. I'll have to get headphones for the next time, but I didn't quite hear the question. But yeah, I think it's very good to have the involvement of the private sector as well. You can sort of complain about the billions that these very rich people like Bezos and Musk have, but they are doing it, spending at least some of it on things that's very worthwhile. They're probably doing it for commercial reasons, but there is a spin-off available. I'm just wondering, will the first of Elon Musk's crew be known as the new generation of Musketeers?
Like it.
Good shout, Terry. I think.
Lakshya, if you could speak up a wee bit. Sorry, I can't. I can hardly hear your question.
I said that's a great shout, and we'll definitely tag Elon Musk after we post this talk out on YouTube and Twitter afterwards.
Yeah.
Any other questions? They've been really great questions. So thank you for everyone who's been listening.
I'm really, really sorry to everyone who I will not be able to answer. I think we have the time to squeeze in a couple more. And Aditya Venugopal asks, I think this might be a question for a botanist, but he says, can we get a rover to plant a plant on Mars with current technology?
Yes, they can dig. They've been able to dig since Viking. So if you were to take but this is again goes back to planetary protection. If you're going to start digging on Mars and putting fertilizer and organics on there, you're effectively messing with the ecosystem. So unless you get it right, and if you've got a lander going down with a ton of soil or manure or whatever you're going to plant your plants in, then you're going to have to be really careful that it doesn't go awry and you start spreading that all over the planetary surface. It can be done. The potato thing was a really neat idea. You only have to see what happened when the hab broke, and it kind of froze over really quickly and died really quickly. It could be done if you had the correct shielding. If you had, there's a talk about going into the caves on Mars and using those as some form of radiation shielding. You're going to need some form of solar energy. Potentially or hydroponic growth system. I don't know. It's doable, as Terry said. If there's a problem, there's usually an engineering solution.
Well, one problem that I have at the moment in my own garden is an even bigger problem on Mars: not enough water. So you do need something to make your own water on Mars, and that you need it for drinking as well. And as you know, if you followed the film or the book The Martian, you can recycle an awful lot of it. But you do need to have the water in the first place. And if you're going to grow crops on a scale where you're going to be, feeding the people that are there, it's going to be a major operation. So you need the energy, you need the technology and so on to be able to do that. It's just not a matter of turning on a tap like we do here.
Yeah, the water recycling is a great quote of yesterday's coffee is tomorrow's coffee.
Yeah.
Awesome. Yeah, thank you for that. Time for one final one, and it's ending on a bit of a sci-fi note. I don't see this happening within the next 15, 20 years either. But there's a question, it asks, can we send humanoid robots to Mars instead of rovers and then control them on Earth by humans using exoskeletons? I think that's a great idea.
It's a really, I'll kind of start on this one, and then I'll hand over to Terry. My company do a lot of work in this area with VR and what's called predictive digital twinning and digital twinning systems, where we're looking at putting people into areas where they're not. And one of the things we've been looking at is lunar surface operations. So being able to put somebody in a room, say the size of a basketball court, with a VR headset on, but they're effectively, as far as they're concerned, they're on the surface of the moon. And there's all sorts of fantastic gadgets you can strap to people to give them that kind of weightless feeling. And I just think it'd be really interesting way to do things. With Mars, you've got the round trip light time, which is a big problem. So if you were a geologist nominally in a VR world walking on the surface of Mars, and you had multispectral head-up displays, kind of like the Google Glass on steroids, where you could look at a rock and say, right, well, that rock's interesting. The hyperspectral image coming back from that is showing me that it's potentially a really fascinating rock. I should walk over to that one and I should pick it up and I should try and examine it using my extended VR presence. You only have to look at some of the robots that they've put on the ISS and the kind of humanoid nature. It's doable. The issue you've got is, as I said, the round trip time, the mechanics of it. If you've got a moving joint robot on one of the harshest environments you can imagine with very delicate electronics, you've got dust storms potentially whipping up, getting into all the joints. Going back to Apollo, those spacesuits were not eaten alive, but they were caked in dust and you couldn't get it off. The astronauts were saying it was weeks before they could get it out of their fingertips and fingernails. And you go onto the surface of Mars, you're going to have the same kind of problems. So it's going to have to be really robust. And yes, you could do it, but the question I always ask when people say about robots, I always say, well, most people over the age of 55 know exactly what they were doing in July 1969 when Neil Armstrong set foot on the moon. And most people, that is the pivotal and the most technically advanced thing that humanity's ever done. It's the greatest technical achievement in human history. But we also bought into it because it was humans. There were human beings involved. Apollo 13, there were human beings involved. And yes, you can get some emotional attachment with robots and rovers, and it would be cheaper. There's all sorts of reasons, but it's innate in the human spirit and the human psyche to explore. If we didn't have Columbus and Vasco da Gama and all the other explorers in history, we wouldn't be where we are now. And that could be a good thing, could be a bad thing, who knows? But we need to explore. It's not up to, robots are great, and at this time we can only go so far with human beings. Potentially Mars is as far as we'll get for the next maybe 100, 200 years. We may not be able to get to Europa or Titan or any of the distant worlds, but I think we really need to put humans there. So yes, again, going back to Terry, of course it can be done, but do we want to?
Yeah, the thing is that when you're out on the surface of Mars, you're going to need almost exactly the same life support system as the Apollo astronauts had on the moon. You need protection from heat, from cold, from solar radiation, from micrometeorites, and particularly from the lack of atmosphere. On the moon, the gravity is only 1/6 of that of the Earth, so you could go around relatively easily wearing a very, very heavy spacesuit and backpack life support system. On Mars, the gravity is 40% of what it is on Earth. So that backpack on Mars is going to be an awful lot heavier. And you have to then allow for things like sweating and so on when you're moving around. There's all sorts of things that are going to be just that considerable bit different on Mars, but you will need exactly the same amount of protection when you're on the surface of Mars as they needed on the moon. And I don't know if you ever tried on a full Apollo spacesuit backpack, but it is one heck of a weight back here on Earth, and it would be almost just half as heavy on Mars as opposed to 1/6 of the weight that it was on the moon. It's not going to be that easy.
Yeah, so the John Young jumping salute is not going to be happening, let's put it that way, unless they get suits like the Martian.
So the exoskeleton, yes, to go back to the original point, yeah, that sort of thing is going to be useful.
There's just a quick question coming from our YouTube live feed from Liam Tracy. And the question is, how long is a day on Mars? Just in case people don't know.
Go on, Terry. You
how long is a day?
Yeah.
It's 24 hours and 37 minutes. which is again one of the things that sort of made Mars so interesting. It was just over half the size of the Earth, but in many ways it had similarities. It had the polar caps, and it had a day that was quite similar to Earth. So it's not quite an Earth twin, but it was similar enough to be very, very interesting.
Yeah, that's 37 more minutes to lie in bed.
Sorry, I didn't hear that again. I'll have to get headphones next time.
That's all right. That's all right. Thank you so much for today, guys. I'm really sorry to everyone whose questions we haven't been able to answer. Thank you for joining us on YouTube. Thank you for joining us on Zoom. A big thank you to Nick Howes and Terry Mosley. A round of applause from your living rooms.
Thank you to our listeners. Thank you so much.
Thank you for staying. Thank you for watching. Please remember to, if you're watching on YouTube, please remember to like, subscribe, and share this video. And if you guys want to watch this again, we'll be uploading it on YouTube tonight, so you can go and catch any of the things you missed. Until then, stay safe, stay healthy, and we'll catch you next Thursday at 5:30 with our next speakers.
Thanks,
All right,
guys.
then. Bye, guys.
Bye.
Bye.